What's up, guys? Good morning. Welcome to a vlog of ours, in which I'll discuss Ian Stewart's Nature's Numbers, or a book by his that's basically correlated to how nature mirrors life itself. So right now I'm going to be discussing, or basically going over, a chapter of his, which is chapter 9, in which basically goes on a philosophical tangent on how life imitates math, or the vice versa. Math imitates life, where we can see fractal patterns where, for example, the Fibonacci sequence mirrors a petal's growing patterns. So yeah, come with me and help discuss what we can see about Ian Stewart's natures. Hi guys, welcome back to a vlog of ours. So right now I'm going to discuss Ian Stewart's Nature's Numbers, and basically we're going to go over a chapter of this, which is chapter 9, in which he discusses chaos, or basically how life imitates math. Because as you can see, if we go over a figure of his, he basically discusses how a droplet forms over a tap. So in chapter 9, Drops, Dynamics, and Daisies, basically Stewart discusses chaos theory and its implications in everyday life, because Stewart is basically fascinated and basically at the same time bored, because in all of its stupefying and its gloriousness, chaos theory is basically super predictable in a sense, if you do understand the topic. He gives us basically three topics, or three things that is a simple phenomena, but if you don't understand it, or basically just look at it at face value, you could basically be stupefied or amazed in a sense. So first off, what happens when a water falls off a tap? Its patterns, how it falls off, and how stupidly predictable it is. Even if you just look at it first glance, you can see that, oh, it's random. But yeah, there's a specific pattern, especially in household taps, on how it falls and how a fractal forms when a water separates from the tap. Secondly, how flowers are arranged and the numbers derived from the Fibonacci sequence. So yeah, if you do observe flowers, especially those with numerous petals, if you seek out, or if you look at them closely, you can see that they are arranged specifically in the Fibonacci sequence. So basically, there's a pattern even in nature, even if basically we don't understand how it works, or how it goes from this to that. And lastly, computer modeling of the growth of fox and rabbit populations. So this entails basically, this is another topic, but if you could discuss this for a little bit, it's basically about exponential growth and how one population of rabbit goes into a exponential growth, where basically it's from two beings into a rapid multiplication of offspring in just a set number of days. Let's go over that. So going back to the topic that we have, let's focus on one of the three topics, or one of the three examples that Ian Stewart gave us. The diagram that you're currently looking at is basically a droplet of water that is falling from a tap. And as you can see, it develops fractal patterns, or such as a pattern is formed even though it seems random. Chaos theory suggests that it is very predictable, in a sense that even though we can look at it as somewhat unpredictable because it's just a droplet of water and different conditions may apply to it, almost all droplets of water form this exact pattern, especially if its viscosity is that of normal water. Now, Ian Stewart basically says that chaos teaches us things about complexity. Now, first, it looks like a classic teardrop rather than a tadpole, round at the head and curving away to a sharp tail. After all, that's why we call such a shape a teardrop.